Hello, in this video we're going to look at an example regarding uniform distribution, and the question code on this is 6.1.5. It reads, the waiting times between a subway departure schedule and the arrival of a passenger are uniformly distributed between 0 and 7 minutes. That's how we know this is a uniform distribution problem, because of that wording, uniformly distributed. We're asked to find the probability that a randomly selected passenger has a waiting time greater than 2.25 minutes. That's P of X, waiting time X, is greater than 2.25. Now we've learned that we can represent probability distributions graphically, and for a uniform distribution, that means the probability is the same all the way across. So what that results in is a rectangular distribution rather than a curve. Our x-axis has all of our wait times in minutes. And write time here, and our minutes go from 0 to 7. And we already know that the shape is going to be rectangular. Why? Because the wait time is the same all the way, or the probability of each wait time is the same all the way across. So in order to get your probability of x, you're going to take the number 1 and divide it by the range of your x values. So the range of our x values is 7 minus 0. We take our maximum and we subtract our minimum, and we get 7. So here, this value is 1/7. Now we have our uniform distribution drawn. Let's relate it to the problem. So we're trying to find the probability that x is greater than 2.275. So that means it could be at 2.2, not 275, but just 2.25, sorry, or greater all the way up to 7, because that's where our distribution ends. So I'm going to shade in this area, because this shaded area represents our probability. You might notice that this shaded area is rectangular. How do we find the area of a rectangle? The area equals length times width. It doesn't matter whether you do what you do for length, which one you do for width. You could say this is L, this is W, or vice versa. We can multiply in any order. I know that my height is 1/7, so I'm going to have 1/7. And the width is going to be from 2.25 to 7. So I'm going to say 7 minus 2.25. That gives me 4.75. So I'm going to have 1/7 times 4.75. And rounding to 3 decimal places, I get 0.679. So the probability that x is greater than 2.25 is 0.679. And you can type that in on your homework. I hope this helps. Please feel free to reach out if you have any more questions.